The first type of question which I am going to discuss is to write in the simplest form the given trigonometric function. Suppose we have to write it in the simplest form. The question which I am taking is say tan inverse of root of 1 plus x square minus 1 upon x, where x is not equal to 0. Understand the meaning of this. And say I'll take one more question which says, say tan inverse of 3a square x minus x cube upon a cube minus 3a x square, where again a is greater than 0, minus a by root 3 less than or equal to x less than or equal to a by root 3. I have taken these two questions wherein you have to write both of them in the simplest form. Now, the simplest form means you have to do some substitution. You have to work on the trigonometric functions and get in the simplest form. To simplify this, we need to substitute for x. And when we substitute for x, it has to be some trigonometric ratio. So we are going to substitute x as tan theta. So if I substitute x as tan theta here, this is tan inverse of root of 1 plus tan square theta minus 1 by tan theta. And all of you know 1 plus tan square is sec square, and sec square under the root will be sec. So tan inverse of sec theta minus 1 by tan theta. Now if either I can multiply numerator denominator by sec theta plus 1, or I can shift in terms of sine and cos, and I am going to do that. So if I write this as 1 by cos theta, so 1 minus cos theta upon cos theta upon sine theta by cos theta. Tan theta also I am writing as sine by cos. So this goes off, and then you have tan inverse of 1 minus cos theta is 2 sine square theta by 2. 1 minus cos 2 theta is 2 sine square theta, and this is theta, so it will be theta by 2. And sine theta is 2 sine theta by 2 cos theta by 2. Clear? So now 2 cancelled, sine theta also cancelled, and you have tan inverse of tan theta by 2. Now tan inverse of tan of theta by 2 is theta by 2. And what is our theta? Tan inverse of x. So this simplification is tan inverse of x by 2. Now this by 2, understand the difference in this and this. Tan inverse of x by 2 is not same as tan inverse of x by 2. Our answer is this. 1 by 2 into this is our answer, and not this. This goes wrong. Yes. So tan inverse of x by 2. Theta by 2. Theta is tan inverse of x. And that's our answer for simplified form of this. Right. Now, if I look at that simplification, tan inverse of 3a square x minus x cube upon a cube minus 3ax square. Coming to this simplification now, we all must observe this. This has a as well as x. Now degree of a is 2 here. Here it is 3. If I substitute x in terms of a, then a will be common from numerator and denominator, and it will get cancelled. Therefore, x has to be in terms of a. And we know 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta is tan 3 theta, right? So I substitute a as the backbone of inverse trigonometric functions is again class 11 identities. So I substitute tan inverse of 3a square. X is a tan theta minus x. So a cube tan cube theta, observe the terms, upon a cube minus 3a x square. So a square tan square theta, and now you will observe a cube common, a cube and a cube cancelled. So whenever you substitute, you must see that a gets cancelled, and now you have tan inverse of 3 tan theta minus tan cube theta. A has got cancelled, therefore I am not writing it. 1 minus 3 tan square theta, and this is tan 3 theta identity. So this is tan inverse of tan of 3 theta, which is 3 theta. And what was theta? Now here understand, x by a is tan theta. So theta is tan inverse of x by a. Right? So our answer is 3 tan inverse of x by a. So we have discussed the simplification of inverse trigonometric functions, and now you can work on the similar questions either from any of the reference books or from textbook. Exercise 2.2, question number 5 to 10. I am going to discuss one more method which is very helpful in solving numerical questions in inverse trigonometric functions. Suppose we have to prove, say, tan inverse of 63 by 16 is equal to sine inverse of 5 by 13 plus cos inverse of 3 by 5. The numerical questions for proving the inverse trigonometric functions. Now, this is tan inverse of 63 by 16. We have to prove that sine inverse of 5 by 13 plus cos inverse of 3 by 5. We would be working on this side to get this side. So, I am discussing triangle method for this. So, if I take sine inverse of 5 by 13 at say theta, so then I have sine theta as 5 by 13. So in a triangle, right triangle, if this is theta, then the opposite side is 5k and the hypotenuse is 13k, and the Pythagoras theorem says this will be 169k minus 25k, which will be 144k, and that is 12k. Right? So I want tan inverse, so I convert both of them in terms of tan inverse. So tan theta would be 5 by 12. So theta would be tan inverse of 5 by 12. What I want you all to understand is this theta, which is sine inverse of 5 by 13, it's same as tan inverse of 5 by 12. Now similarly, I will take cos inverse of 3 by 5 as say 5. So cos phi is 3 by 5, and again we have another right triangle where say this is phi. Cos is adjacent by hypotenuse, and we know Pythagorean triplet, this becomes 4k. So tan phi becomes 4 by 3, opposite by adjacent, and therefore we have phi as tan inverse of 4 by 3. That means the RHS of our question is nothing but tan inverse of 5 by 12 plus tan inverse of 4 by 3. And just now we have discussed the identity, tan inverse of x plus tan inverse of y would be tan inverse of x plus y, so 5 by 12 plus 4 by 3, upon 1 minus xy, 5 by 12 into 4 by 3, and if you take LCM and simplify this, you will get this, because 15 plus 48 will be 63, and this is 36 minus 20 will be 16, and of course denominators would get cancelled and you will get LHS. That is the simplification of the proving questions with numerical can be done with triangle approach, right? So you can work on these questions also, and miscellaneous exercise of inverse trigonometric functions also, right? So try to cover up the whole chapter in 1 or 2 days and become good at